Alright, let's get started. We are on exercise 14B. Last lesson we learned about the factorial. Very exciting. And we learned that we can use the factorial if we want to put some people in order in a line. Okay, so we used the example of 5 people at a bus stop. How many ways can we put those 5 people in a line? It was 5 factorial. Okay, so we're going to be using that a bit today. But we have some other parts in here that we need to use as well. So let's have a look. This section, we're doing counting ordered selections. In this section, we want to develop a systematic way of counting selections that will be later applied to probability problems. So remember, we're still just learning how to do counting methods before we even get to the probability part of this topic. There are 2 dominant questions. First of all, the first questions are the things that I'm trying to use here, are they going to be ordered or unordered? When we're using the factorial, we're putting things in order. But there's going to be some questions where they're not in order. So whenever you read a question, you're like, is the order important or is it not important? That's your first big question. And then, if they are unordered, is repetition allowed? Can you use the same thing twice? Okay? So there's a few techniques we're going to learn about. The first one, which you've probably seen before, or you will have seen before, is the multiplication principle. Rule number 1. If an ordered selection can usually be regarded as a sequence of choices made one after the other, so for example, if you went to a restaurant, you might have to choose an entree, a main, and a dessert, right? What if there is 5 entrees, 8 mains, and 4 desserts? That's what this says right here. The number of possible 3-meal combinations would be just multiplying those numbers together. That's why it's called the multiplication principle. There is 5 entrees, and we times that by 8 mains, and we times that by 4 desserts. And when you type that all in, that means there is 160 ways to choose an entree, main, dessert. There is a little catch on that you're probably already thinking, what if I only wanted 2 courses or 1 course? But we're not going to worry about that yet. We have to choose an entree, main, and dessert. We won't get any fancy stuff just yet, okay? If one event can happen in A ways and a second event can happen in B ways, so this is like a generalization here, that means that the successive events is we're just multiplying them together, A times B or AB ways. It's just giving you a little bit of a rule. Textbook likes to try and give you rules for everything, but just remember the multiplication principle is you're just multiplying the possible outcomes together. Okay, and this is here's their lovely general one. This will mess with your brain a little bit. If you don't know how many things, this is the really general formula. If I've got 2 courses, I'd go the first course times the second course. If I had 3 courses, it'd be first course times second course times third course. But what if I had R courses? You just keep multiplying however many courses there are until you've multiplied them all together. So that's what that formula means. It just looks a little bit confusing at first. Jess?
Do we use the multiplication principle when they're ordered, like it says up the top, number 1?
Yes, it's for order, yes. Okay. All right, so let's look at the examples. Very common example here. A website password requires 4 letters and then 3 numbers. How many different combinations or how many different options do we have for this? Now, the box that is drawn here, this is basically just a thinking space, okay? This is to help you organize your thoughts. You will not have boxes like that in your textbook, and I don't expect you to draw them, okay? It's just to help us as we're just learning this to go, first of all, I've got to think about the very first letter. If you were sitting there trying to make up a password, the first thing you have to do is choose the first letter, right? So, how many options do you have to choose one letter? 26, your letters in the alphabet. 26 options for your first letter. Now, passwords don't have to make sense. They don't have to be words. And you can obviously repeat things, right? So, if I move on to my second letter, how many choices do I have? 26 again. So every letter that I choose here, first, second, third, and fourth, there are 26 options for me to choose from. Okay? Then, because that's my 1, 2, 3, 4 letters, then I have to choose 3 numbers. How many numbers? 10. Good. Don't forget the 0. Yep. So there is 10 numbers to choose from for the first, second, and third number. So all the multiplication principle says is that you would multiply those things together. That, times that, times that, times that, times that. All those numbers you would times together. Multiplication principle.
26 to the power of 4.
Yeah. If you wanted to, you can rewrite that, definitely. 26 to the power of 4 times 10 to the power of 3. That is obviously going to be a very big number, and you would hope so because this is password for the computer, yep? So it's 4, 5, 6, 9, 7, 6, 0, 0, 0. Right?
We incorporated the order as well.
That is putting them in order, isn't it?
Like if the order was randomized.
That would be a different question. We're not going to do that just yet. Okay, that makes it a bit more complicated. We will get to that. Okay, so part B. How many combinations are available if the password is extended now to 8 digits? We're going to add an extra digit on there. And that last digit is going to be a symbol on the top of your keyboard. So your exclamation mark through to your bracket. Okay? So basically the first part is the same. So you've got 26 choices for each one of your letters. And you're going to have 10 choices for each of your numbers. How many symbols are there on your keyboard?
No idea.
There's 10 as well, because it's one for each number.
Isn't there like slashes?
Oh, no, it's talking about the ones that are, because it says how many available on the top past the top keyboard. There, okay. It says from the exclamation through to the bracket. Okay, so it says exclamation through to bracket if you look at keyboard, which is talking about the ones on your top.
1 to 9.
All right, don't get technical. I'm just going to say 10.
1 on 0.
Yeah, which is the bracket. So from 1 all the way through to the 0 is 10 numbers. Yeah? Okay? So multiplying all those together, again, we can write it in the shorthand form. 26 to the power of 4 times 10 to the power of 4 this time. It's going to add an extra 0 on the end, isn't it?
Yeah.
So by adding one extra digit, we have 10 times the number of different options for a password. That much harder to hack by adding one extra digit. We don't hack passwords, okay. All right, next one. Ordered selections with repetition, okay? How many 4-letter words can be made from the letter A, B, C, D? Now, I use the term word loosely. These words are not going to make sense. You can't even make one word out of the letters A, B, C, D that actually makes sense that I can think of. It's just how many different ways can you arrange those 4 letters, okay? If repetition is allowed, that is a key thing in there. Oops, I'm not on my highlighter. If repetition is allowed, you always want to look out for those kind of key words. I'm allowing repetition. So that means if I choose the A the first time, I can choose it the second, the third, and the fourth time as well, okay? So thinking of that first letter, how many options do I have? 4. And because I can repeat, how many options for the second? 4. How many for the third? 4 and the fourth. Okay? If I wasn't allowed repetition, that would have become a factorial question because it would have been 4, then I've used the A, then it would be 3 for the next one, 2, then 1. So that's the difference between a repetition is allowed and repetition is not allowed. Okay, so...
Repetition is not allowed as a factorial.
Yes. Is 256 for the answer for that. Now, again, if I wanted to generalize that, here's a general statement for ordered selections. If I had R letters in a word to form N distinct letters, it would be N to the power of R. So 4 was my number of letters, and I wanted to repeat it 4 times, so I did 4 to the power of 4. Okay? So that's just giving you a formula-based thing to look at if you like. Next page, question 2. How many 3-letter words can be formed from the letters in the English alphabet? Now, sometimes you do have to make a bit of an assumption. Do you think I would be allowed to repeat the letters in there or not? Yes, I'm going to go with yes. Usually they would say can't repeat, and yes. We're not saying that these words would have to make sense because we're not going to go and filter through which words make sense and which ones don't. Just how many 3-letter words can I make from the English alphabet? And we're going to assume that AAA is a word. Okay? So, can we do it the short way? How many letters can I choose for the first? If I've got to choose 3 letters, right? How many for my first choice?
26.
Second choice?
26.
And 26. So, without the boxes, we don't have the boxes here. You could just write 26 times 26 times 26 or 26 to the power of 3, which is 17576. How many of these words do not contain any vowels? Okay, so what you want to do is you want to say, I am not allowing any vowels in my selection. So how many letters are in the alphabet that are not vowels?
21.
21, good. So what is it going to be?
21.
21 times 21 times 21, or 21 to the power of 3. Good job, Ben. Which is 9,261. How many contain at least one vowel? Now we know how many possible words there are all together. Some of those would have vowels and some of those would not have vowels. This is the total. These are the ones that don't have any vowels. So what do you think I should do to find the ones that might have 1 vowel, 2 vowels? Yes?
5 at the start. I can go 5 times 26 times 26.
No. Easier than that. Just subtract those 2 things. Yeah. All I need to do is go, this is all of them. If I take away the ones that don't have any vowels, then I will have the ones that have some vowels in them. I don't care if it has 1, 2, or 3. Okay, so all I do is go 20, I'm going to go from the start, 26 to the power of 3 minus 21 to the power of 3. Just don't have to write those big numbers. And that is 8315. All right, next question. We're doing ordered selections without repetition. Counting ordered selections without repetition typically involves factorials. We've mentioned this already, because as each stage is completed, the number of objects is going to decrease by 1 because we're not repeating that letter, right? Or that number, whatever it is we're using. So for example, and we've touched on these ones already last lesson, a group of 9 teenagers are waiting to be served at a cafe. Sounds a bit like my bus stop, doesn't it? They are randomly assigned a number from 1 to 9. Basically, you're putting them in order, in a line from 1 to 9. Okay, how am I going to do that? 9 factorial. Because if you remember, I would have 9 people. Hey, wait, I might actually have 9 people here. I do. There is 9 people. If I was going to randomly choose who am I going to give number 1, I have 9 choices to give my number 1 to. I'm going to give it to Isaac, okay. Then I've got 8 people left to give the number 2 to, and then I have 6. What am I up to? 7, then 6, then 5, then 4. Okay? And each time I give one of you a number, it decreases by 1, which is my factorial. Okay? So that is... Everyone's okay typing those in their calculator, I hope. Okay, we're well familiar with the factorial button by now. All right, part B. We don't want to just stick with plain boring 9 factorials. That's too easy. Okay, so part B. One member of the group needs to be served first. So you're going to get questions where there is what we call a special case. Someone in there needs to be treated specially from the rest of the group. And so in this case, we have a special case because one person must be first. When that happens, you deal with the special case first. So if that one person needs to be first, if Isaac has to be first, I only have one choice of who I give that first ticket to, right? So there's one way that I can give that first ticket out. It has to be that one person. Then all I have is I still have 8 more of you here, 8 more people that I have to put in some kind of random order. 8 factorial from there. Now, you don't need to go 1 times 8 factorial, do you? That's not going to make a difference, that 1 there. But it is working out in your head. I've placed that first person and then I've ordered the other 8. Okay? So it's just a way of processing your thoughts to write that 1 down. Okay. Question 4. In how many ways can a class of 16 select a committee consisting of a president, a vice president, a treasurer, and a secretary? Okay, so I've put the boxes back in here to help us organise our thoughts here. I've got 16 people, but I don't need to select 16 people. So I'm not going to go 16 factorial because not everybody's going to get selected. Only 4 of them are. right? Only 4 people out of that 16, the president, vice president, treasurer, and secretary. So assuming that everybody is equally likely to be picked, like always, we don't try to weight anything in this topic. How many different choices do I have for picking a president? There's 16 people in the room, so I've got 16 choices. Once a person's been selected as president, you hope they can't also be vice president, right? So how many choices for vice president? 15. And how many for treasurer? 14, and then secretary? 13, because each time one person's been selected, it's going to decrease by 1. I'm just not going all the way down to 1 this time, okay? So this is multiplication principle. We can do it like that, multiplying those together, and we get 4, 3, 6, 8, 0. However, I'm going to show you something new right now. We have our factorial button if I was putting all 16 things in order. But there's something that we call a permutation, which is when we want to put things in order, but not all of them. Okay? So on your calculator, you're going to be able to write something like this. I have 16 things. The P stands for permutation, and I want to put 4 of them in order. Okay? So, that's why I need my calculator here. So on your calculator, you type in the 16, then you need to press Shift and the times button. Okay, because you see behind that times button, you can see the little P, the NPR behind there. Okay, and it brings up a P, and then you just type the 4 and press equals. Okay, and it will do it for you. It gives you the exact same answer. You just don't have to write out the 16 times 15 times 14 times 13. You have options. Sometimes it's a bad thing to have options, isn't it? If I say always do the question this way, maybe it would be easier. But unfortunately, you do have the choice. You can write it out using the multiplication, or you can use that permutation button. Okay, get the same answer. All right, so that's our little intro to our next section here, which is permutations. So permutations, and the one thing, the biggest thing, I'm going to write it in red. Order is important. Because there's going to be 2 of these things we're going to learn about. We're going to have the permutation that we're focusing on in this first lesson. And we're also going to learn about one called a combination. The P, the permutation, is when the order is important. When I select that president, vice president, or when I'm putting people in a line, the order that I put them in is important. Okay, if I'm picking who's winning the Melbourne Cup, it matters who's first, second, and third. The order is important, right? Okay, so permutations are when the order is important. That's the biggest thing you need to remember. All right, so we've talked about this. The symbol NPR is what we use. Okay, so N means that's the number of things that my choices. So in this room I have 9 choices. And P means I'm going to put you in order. And the R is how many of you am I going to put in order? So if I just need to pick a first, second, third, I'd go NPR. I want to put 3 of you first, second, third. Okay? That's the idea. All right. Here we go. Oh, okay, yes. All right. How many people in the room just like to be given a formula to use, and how many like to know where it comes from? So how many people just go, give me a formula, don't tell me about it, just give me a formula. Just give me a formula. We have a just give me a formula here. And so I'm assuming the rest of you like to know a little bit of where a formula comes from. Okay, well, this is for you. Ashton, you can hum to yourself sweetly for a little while, all right? Okay, so I'm not going to be asking you to derive this, but there's a little section in here where I'm going to show you where I'm going to give you a formula for permutation as well, okay? Which is going to help us do some other lovely proofs down the track, okay? So that's what this bit here is. If I had NPR, that's my permutation that I've just told you about. That means that I have N objects or N people. So that if I was doing it the long way with the multiplication, that means I would have N people to start with. Then I'd go, oh, all right, my next one, I'd take one off, N minus 1, N minus 2, and I'd keep going, depends how many people, right, that I want to put in a line. I'd keep going, if there was 4 people I'm up to here, I'd go N minus 3, And I just keep going. If I wanted 5, I'd keep going. But we're doing a general formula here. We're going to go to R. How on earth do I go to R? Okay, so this is my ... section. How do I get to R objects? Now have a look here. If I have one object, I have n. If I have 2 objects, I have a -1. If I have 3 objects, I have a -2. 4 objects is a -3. What do you think R objects is going to be?
N minus R.
N minus, it's not, that's not the same as that though, is it? It's not just n minus r, this is plus 1. This is always 1 bigger than that. Okay, that's because this one doesn't have 1 taken off it, right? Okay, the first position doesn't have 1 taken off it, but after that we do, okay? So this one down here, I would go n minus r, but it would have to be plus 1, because it's always 1 bigger than it. Okay, so that is the repeated multiplication of what a permutation is. Okay, so here it is written out. NPR equals, and there's all those things multiplied together. I don't want to have a ... random thing in there. I want a formula I can actually substitute into. Okay, so we always like our little math tricks. Okay, I know what n factorial is, right? N factorial is something that I could work with. If I had an n factorial, I'd start at n and I would just keep multiplying all the way down to 1, right? Following the top line all the way across here, just forget that there's a bottom there for a second. I'd start at n, I'd multiply -2, -1, I don't care where r is in the middle, and I'd keep multiplying all the way down until I got to 1. Okay, that's n factorial. I don't have that, unfortunately. But if I wanted that, and I just divided by over itself again, all I'm really doing is timesing a 1. This is like, makes me think of surds when we're rationalizing the denominator. I want that bit in there. I can't just time some random number in there. So if I divide it by itself, I'm only timesing by 1. Yeah, do you see what I'm saying here? So that whole top line, when I put it all together, I just take all that top line together. That is my n factorial. And on the bottom, I don't have any ... I just had this bit in here. I had from n minus r all the way, well I do have ... but it goes all the way down to 1. Okay? So this is where the formula comes. The whole top is just n factorial, it's n with everything underneath multiplied together. And then on the bottom, my first part of my factorial is n minus r, and then everything underneath will be multiplied together. And that there is the formula for a permutation. Now, most of the time, for the type of questions we've been doing so far, you don't need the formula because your calculator does it for you. You just go, what did we do before? I don't know, what did we do before? 16p4, and the calculator does it all for you. But unfortunately, like always, I'm not going to just stick with giving you some number stuff. Sometimes there's going to be some stuff with letters, and you're going to have to unroll things, and there's other fun things that can happen. So that is the formula for a permutation. And you know what it's doing? You're taking n objects and you're putting them in order. So if it was the 16 from before, you could try this. We had, what do we have? 16p, looking back up, 16p4. That would mean that the 16 is the n, so it would be 16 factorial on the top, and it would be 16 take away 4 with a factorial on the bottom. And that is what your calculator is actually doing. You can type that in this way with the factorials and see if you get the same thing yet again. So there we go, 3 ways to do it. We can do it with multiplication, we can do it with the P button on the calculator, or we can do it with that lovely formula. Jess?
Is that just for permutations?
That's just for permutations. There'll be another one for the combinations that we're going to learn. All right, so nice easy example here to start with that you're all going to love. Use your calculator, please, to practice your permutation button. Can you tell me what 9p4 is equal to?
3,024.
Yes. All right, all of you do it, even though Ben was the first. Make sure you all can get that and you get comfortable with using that P button. Now do the second one, 6p2 is 30. The bigger your number of selections and the more you pick out of it, the bigger that number is going to be. Okay? All right, so example number 2. Not number 2, number 6, but number 2 of this section. All right, a bag contains 5 balls of different colours red, yellow, blue, green, and white. In how many ways can these 5 be arranged with no restrictions? Now, not every question is going to be a permutation question from here on in. We've still got other skills that we've learnt. I have got red, yellow, blue, green, and white. I've got 5 things, 5 balls, they say, that we're putting. We want to pull them out of a bag, if you like, and we want to put them all in order. How would I do that? Yes, I'm using all of them. So I don't need the permutation because I'm using all of them. Okay? We only need the permutation if I've got 5 of them, I only want to select 2 of them. I want to select less than what I've got. If you're using all of them, the quickest way to do it is just to go 5 factorial, which we've memorized because we've used this one a few times now, 120. Okay? But then we want some special cases. So it says, part B, yellow has to be first. So if there's a special case, we deal with it first. If yellow has to be first, how many things can I choose for the first? 1. Okay? Then I still have 4, whatever these balls are. I have 4 left. How many ways can I arrange them? 4 what? Factorial. Good. If the first ball is not red or white, so it can't be the red or the white, it can be the yellow, blue, and the green. So how many things can I choose for the first one? 3. Okay, 3 for the first one. How many are left after that? 4, because assuming that I chose the yellow, that means that all 4 of them are still in there, even though those other ones could have been first, they weren't. So that would be 4 factorial after that, which is 72. Okay, if blue and green must be together, we haven't done one of these yet. This is a new type of question. When you've got 2 things that have to be together, okay, they don't have to be first together, they don't have to be last together, they just have to be together somewhere in that order. When you have 2 things that have to be together, consider them to be a group. You make them like one group. Okay, so I have, what were my colours again? I have red, yellow, blue. No, not blue. All right, gonna have to highlight so I can organise my thoughts here. The blue and the green have to be together. So I have my red, yellow, and white. They're all separate, but my blue and green are forming one of their own little groups here. So how many things am I putting in order? If they're 4, very good. But, remember we're putting these in order, and the order is important. If that blue and that green are in a team here, it could still be in 2 different orders. It could be blue then green, or it could be green then blue. Couldn't it? Yeah? Do you see what I'm saying? So we've ordered our 4 groups, but then we also have to order what's inside that little group. So I have to times that by 2 because there is 2 things within that group that can be ordered as well. Okay? Now, if there were 3 things inside that group, it's not times by 3, it's actually 3 factorial. Now, this could be 2 factorial as well, but what's 2 factorial? Just 2 times 1, which is 2. Okay, so 2 factorial is the kind of one we get a little bit lazy, or I get a little bit lazy. When it's a 2 factorial, I just go, it's just 2 because 2 factorial is 2, right? But as soon as there's 3 things in that group, it's 3 factorial. 4 things would be 4 factorial. You get the idea, all right? So that is actually 48 different ways that we could organise those. Okay, permutations as a set. We're getting close to the end now. A permutation is a set is an arrangement of all the members in the set in a particular order. We've talked about that. The order is important. In order. If there is n members, then the number of permutations is, okay, so we usually see NPR, right? So this is trying to show you if I have 5 things and I want to put 5 things in order, it is 5P5 or NPN, right? It's just saying I have 5 things and I want to put 5 things in order. So the number here is actually the same as the number there. Using the permutation formula that you probably haven't memorized yet, I'll write it over here. It was n factorial over n minus r factorial. That would mean n factorial on the top, and normally it's n minus r, but it's n minus n factorial. What is n minus n? 0 factorial. And this is another reason why we needed to know what 0 factorial was equal to, because it can come up in here. Do you remember what 0 factorial has to equal? 1. Okay, and this is another reason why, because we cannot have a 0 on the bottom of a fraction, or all of a sudden we can't do any math with this anymore. Okay, so 0 factorial is 1, which means that's just n factorial. Whoa, highlighter. N factorial, which we already knew, but there it is shown with the formula that it works that way as well. All right, example 7. There are 7 horses in a race. How many different orders can the horses finish?
7.
Which way, sorry?
7 factorial.
7 factorial. Anyone want to tell me another way to write that?
7
Yep, another way to write that?
and
7p7. You got 3 choices now. I didn't even write the third one. You go 7 factorial, you go 7 things that I want in 7 things in order, so 7p7, or you go 7 times 6, okay? All right, so that makes, you don't have to write both of them. You would just choose whichever one comes to your mind first. So Ben had the 7 factorial, which was perfect. I would probably do that too, to be honest. But if you, a lot of people tend to start liking these permutation things because they are quite good and you can use them for quite a lot of things. All right, so if you get more comfortable with that, you're welcome to use that method as well. Part B, how many trifectas, here we go, I'm not a Melbourne horse racing person, but anyway, trifectas means that you have to have first, second, third in order, right? So, I don't care about 4th, 5th, 6th, 7th. I have 7 horses and I need a trifecta. What am I going to do? Oh.
7p3.
Yes, you, sorry, no, you. I think I heard between what you were saying. So you can go, there's different choices. You could go 7 times 6 times 5, repeated multiplication. You don't want to go 7 factorial because that goes all the way down to, we're putting them all in order then. But use our permutations, okay? I have 7 horses. I've got to put them in order, and I want to put the first 3. I need to put the first 3 in order. So 7p3 means that there is 210 different ways that you could choose a trifecta, assuming that all the horses were equally likely to win, which they never are, but anyway. All right, a general counting principle is to deal with the restriction first. I already mentioned that, but worth making sure you've remembered. Always deal with any special cases first. So when counting ordered selections, deal with any restriction first. Place the boxes in order in which the selections are made, if you're wanting to draw your boxes, but that's what the boxes do. It helps you put them in order of how you're selecting things, okay? There are 6 boys who enter a boat with 8 seats, 4 on each side, okay? In how many ways can they sit anywhere? All right, so you're picturing some kind of boat. You got 4 seats on this side and 4 seats on that side. Okay, you could even number them if you wanted to. The first person walks onto the boat. How many choices do they have of where they're going to sit? 8. Okay, we don't really care about the left and right at this stage. It says any random order. Second person walks onto the boat. How many places can they sit? 7. Third person walks on. 6. Fourth person. 5. 4. And you see it decreases each time. Okay, I only have 6 people on the boat. Okay, there's 2 spare seats on there. Okay, so I stop at the 3. That's using the multiplication. What is the alternative method? Yes. So sometimes, especially when it's a bit of an unfamiliar situation, it can still help to draw out something to try and put your things in places rather than going straight to the permutation. All right, more restrictions. Part B. 2 boys, A and B, sit on the port side. I don't remember which side that is. That left or right? Anyway. And another boy, W, he sits on the starboard side. I don't remember which is port and starboard, but anyway. Okay, so 2 of the boys have to sit, so A and B have to sit on, I'm just going to call it left, on the left side. Okay, so deal with the restrictions first. Those 2 boys, we're going to give them first choice. Here they come onto their boat. They have to sit on the left. How many choices do they have? 4. So let's go 4, and out of the 2 boys, they have to choose there. So there's 4p2 choices for those 2 boys. Then we had another restriction. We had another boy who had to sit on the right side. Okay, how many choices does he have?
4.
He has 4 choices, and there's only one of him choosing though, right? So 4 choices, one boy's got to make that choice. Okay, we've dealt with the restrictions. Now we still have some other people still to sit on the boat. Okay, how many people have we seated so far? 3. How many people are left?
5P3.
That's right, there's 3 people left to sit and there's 5 seats still left, right? So there's 5P3. Very good, people. Doing well. 5P3 ways of sitting the people who are left. So you'd have your multiplication signs in between those. Yep, you times each of those. So go 4P2 times 4P1 times 5P3. And what do you get? Yeah. Very good. Okay, so you might have questions that don't just have one permutation, and then we got 3 in that one. Okay, we had little groups that we had to order put in there first. Fun times. All right, last question. Yep. From the digits 1, 2, 3, 4, 5, and 6, how many numbers greater than 4,000 can be formed? Okay, so 4,000. I've got 5 numbers there though, don't I? Okay, so I've got 5 numbers, and this has only got 4 digits. That's only got 4 digits. So anything that's a 5-digit number is automatically going to be bigger than 4,000, right? So I could have all the possible 5-digit numbers, but I could also have some 4-digit numbers, assuming that the first number was larger, 4 or larger. It could be the 4 as well, because then they're not, so 4, 5, and 6. All right, so we've actually got 2 different things that we're going to have to put together here. So we look at them one at a time, okay? So first of all, the 5-digit numbers. How many ways can I order 5 numbers? Yes, sorry? Yes, say louder? 5 factorial. You don't even need the boxes. Look at that. Let's do it on the side then. 5 factorial, putting 5 things in order. Okay, if you don't need the boxes, that's fine. Or if you want to fill in the boxes, it's just 5 times 4 times 3 times 2 times 1. Putting those 5 things in order. Okay, the 4-digit numbers are a little bit more fun. So, you've already told me that first digit, I have got 3 choices to choose from. It could be the 4, the 5, or the 6 to be larger than 4,000. Then, I have how many numbers left?
3.
One of them's been chosen. Let's say it's that one. Or actually, it won't be that one. That one's been chosen. There'll be 4 numbers left. And I need how many? 3. So let's go 4P3. Okay. Times those together. 3 times 4P3 is?
Good question.
72. Good. All right, B. Oh, no, I haven't finished, sorry. I found how many 5-digit numbers. I found how many 4-digit numbers. I really should find the total. Okay. We need to put those, just add those together.
92.
Yeah, so 120 plus 72, and there's 192 numbers that could be made larger than 4,000. Part B, how many 4-digit numbers would be even? Okay, now this messes with your head, because normally we start at the beginning of something and we work through to the end, but this case, it's my last digit that's the one that's critical here, isn't it? So I actually have to choose the last digit first. Okay? So, yeah, there is 1, 2, 3 even numbers to choose for that last digit. Okay? So it could be 3P1 if you want to put it as a permutation. Yeah, I can do that. Do you want me to write that there as well?
3P1.
Is that what you just said?
I said 1P3.
No, you got 3 things and you want to choose one of them to go in that last place. Okay? So, okay, oh yes, getting ahead of me. Then I still need to choose 3 other numbers and I have 4 left, right? So it's 4 things left and I need to choose 3 of them for the other 3 digits, first, second, and third that weren't as important, but anyway. Okay, so when you times those together, that makes 72 again, because it was actually the same as the one above. Okay, here is another little trick. Here is another little trick that can come in handy, because some questions, they get a lot of different parts moving in there. If you have 4 digits that you want to put in 4 digits? Yep, 4 digits I want to put in order. So this is for part B. 4 things that I want to put in order. That would be 5p 4 ways just to put, without worrying about if it's odd or even. Don't care if it's odd or even. If I just have 5 numbers and I want to put 4 of them in order, I'd go 5p4, which is 120. To do an odd or an even from there, all you have to do is what fraction do you have up here? Okay, so I have 3 out of 5 are even. So I would go 3/5 of those numbers. So 3/5 of 120 is going to be even, which also gives me the 72. If I wanted the odd, I would go 2/5 times 120 to find the odd ones. Which sometimes the questions are, it's like a 50-50 chance. If you already know the total number of ways and it says how many of them are even, you just got to halve it. Go half of them are going to be even. Okay, it just makes it faster sometimes to do it that method. All right, so that is 14B done.
Yay.